Please help me to welcome to the stage Kelley Robinson, who's with Twilio, to talk about how to protect your phone verification flow from fraud and abuse. Kelley, welcome.
Thanks so much. Hey folks, good morning. Thank you for joining us today. I wanted to start out with a story that kind of got me on the path of what I'm going to be talking about today, which was about a year ago, some of our customers and some of the developers that I work with started coming to us and saying things like, we're seeing someone who's signing up repeatedly, immediately triggering two-factor authentication enrollment, unenrolling, and then re-enrolling with a new phone number. This really doesn't have any account takeover impact to us, but it's costing us a lot of money for the Twilio service. And we've been kind of at a loss for what the motivation is here and why, what the end state is. What is this attack? What is happening? And why is it costing us so much money? And so we got a few of these questions coming in. People were wondering why. They were upset about their bills. And so we started trying to figure out what is the motivation. Why are these attackers doing this? How are they making money off of this? And who is benefiting? So often the attack looks something like this. You have your kind of normal sign-up process, normal phone verification flow, normal amount of SMSs that are going through your system. It's a little spiky, but whatever. But you'd see a big spike suddenly in traffic that the customer wasn't expecting. And at the time, we weren't blocking this proactively because a lot of verification traffic is very spiky, as I'm sure some of you know. You run a promotion to do some kind of sign up. Your identity spikes on certain times, days, based on whatever your business is. And a lot of this traffic was happening in places that we were seeing legitimate traffic too. And so like this customer mentioned, this wasn't really an takeover ploy, but it was costing people unnecessary money. And I think the natural follow-up question here that a lot of people have is I have this kind of vague y-axis here with a lot of dollar signs. How much money is this costing people? It's costing people tens of thousands of dollars, if not hundreds of thousands of dollars. And so one of the things that I'm going to be talking about today is this very specific attack on phone verification flows called SMS pumping. And we figured out how to prevent it. But regardless of how well you think your phone verification forms are protected, the next 15, 20 minutes that we talk could save you tens of thousands of dollars, if not hundreds of thousands of dollars. And so that's what I'm here to talk to you about. It's pretty specific. It's a pretty specific attack. I'm not going to be getting into a lot of other, there's a lot of SMS attacks out there, as I'm sure we're all familiar with. But the specific one I'm going to be talking about today is the SMS pumping side of things, and how you can use some strategies to prevent this that will also help you protect your sign-up forms from other types of fraud and abuse. So my name is Kelley Robinson. I work at Twilio. If you're familiar with Twilio, you might know that we make a lot of money off of sending a lot of SMS service, and so this is why we're familiar with this attack, is because a lot of our customers are using this as a technique for verifying phone numbers, adding two-factor authentication, whatever it might be. I focus on Twilio's account security products for things like phone verification, two-factor authentication. And a lot of my job is working with developers and customers on the self-service experience for our APIs, making it easy for you to use them. So talk to me if I can help you with that. This talk is not about Twilio specifically. It doesn't matter who your phone verification provider is here. The stuff that I'm going to be mentioning will be widely applicable no matter what you're using. So this is just why we know a lot about this, why I'm familiar with this problem, but you do not have to be a Twilio customer for this to matter. So this talk does assume that you are sending text messages or verifying phone numbers for some reason. I don't know what that reason is. I don't really care what that reason is. Again, this can save you a lot of money if you are verifying phone numbers. Again, I'm not going to get into debating the merits of SMS two-factor authentication today. Happy to do that after if you want to talk about that. And again, this is not going to get into some of the other types of fraud that we commonly see with SMS. But what I am going to talk about is going into what SMS pumping is, so that you have a better understanding of what this attack is doing and what you might be able to look out for, including how it works and kind of the unintuitive way that fraudsters are making money off of this. It's not a very straightforward situation of how they're making money, and so that's why I think a lot of customers were originally confused. And finally, we'll spend about half the time talking about the strategies that you can use in order to stop this kind of attack and potentially other types of similar attacks. All right, let's start with what is SMS pumping. You might also hear this called artificially inflated traffic, AIT, SMS toll fraud. There's like a lot of different names for this because it's a relatively new attack that we're seeing, and so I haven't heard from a lot of industry folks like what there's like an agreed upon name for this, but we've been calling this SMS pumping, and so that's the word that I'm going to be using the most today. So SMS pumping, SMS toll fraud causes inflated traffic to your application with the intention of making money and not to steal information. So just re-emphasizing that this is not an account takeover ploy. It's not about gaining access to accounts or anything like that. It's simply about financial gain. And as you know, attackers will find lots of ways to make money, and this is one of the ways that they've done that. But it is one of the reasons that it doesn't always register in the threat model until you start to see these big bills coming from your verification provider. And it's not really like a DDoS attack because the system needs to be up in order for fraudsters to make money off of this. So they're not trying to take your system down. They're just trying to send enough requests as quickly as they can, but without you noticing, so that they can continue to make money off of this until you stop them. All right, so the attack starts with some kind of phone number input field that will send an SMS to a number that the attacker can specify. And I included a few examples here because while I focus this on phone verification, that's where we see it the most often, this can also happen if you have any kind of these open forms that are sign up for marketing updates, enroll in two-factor authentication. The other one that we see sometimes is text me a link to this app, this mobile app so that I can install it on my phone. Basically, it's important that the attacker can specify the phone number that they're triggering a text message to, because that's important how they make money off of that. The content of the text message does not matter at all for this type of attack, which is why you often see that in some of these form messages. So they're using some kind of template here. They don't care what's included in the text message. They just want to trigger the text message and trigger a billing event to a specific phone number. And so that's one of the things that you want to look out for. If your application has anything like this is something that you might be susceptible to. And attackers, obviously they look like this person. Google stock photos of hackers. It's just like a fun corner of the internet. But they're looking for the equivalent of the unlocked door, right? And they really need to be able to send a lot of text messages, and they need to be able to change the phone number easily, which is why if you have a form that's open to send a phone verification to, that's a pretty easy way and a pretty common way for them to specify a phone number. Your form probably, and it probably should, allow people to edit their phone number in case there's typos. There's all these legitimate reasons that you would have this open, but they need to be able to trigger a lot of text messages. So they find a form that doesn't have a lot of controls around it, and it's easy to send a lot of messages. Maybe you have an API that's exposed as well, or maybe they can script something on the front end that is able to trigger a bunch of text messages to be sent, hundreds, thousands, tens of thousands of messages. And one way that you can identify that this attack is happening, if they're sending the messages to these sequential ranges of numbers. So number ranges are controlled by the same mobile network operators, and that's important to how the attackers are making money off of this. And so if you're seeing spikes in your traffic, one of the first things that you're going to want to look at is where are these numbers all being sent to? Are they being sent to the same country code? And then if they're being sent to the same country code, is it a country code that I'm currently running a promotion in? Did we just run an advertisement on Sunday Night Football for something? Maybe you're expecting some traffic there. But if you're seeing a spike in traffic to Vietnam and you're I don't run any ads there for signups, maybe that's a signal that you're seeing an attack like this. And what you'll end up with is these spikes in traffic from all of the SMS pumping, and that can, again, cost you tens and thousands of dollars. If you break out the traffic by country or carrier, you'll start to see that there's usually one mobile network operator that's to blame. And again, that's because that's important to how the attackers are making money. So we've seen this in places like Vietnam. We've seen it in places like Nigeria. And if you're a US company not doing business in that part of the world, maybe you can block all traffic to those countries. But we've also seen it in places like Switzerland and the United Kingdom. And so if you're a European bank doing business, you probably don't want to block a lot of traffic to the UK if that's you're headquartered in London. And so that's one of the things that one of the early stages of this was okay, we'll just block traffic to a specific country, but that doesn't always work out because some of these attackers get sophisticated and are using different mobile network operators in their attack from countries where you're doing legitimate traffic. And the reason that you'll see this from a specific carrier is that the carriers are in on it. They're working with the attackers. They're part of the scheme in order to make money. And so they have these revenue sharing agreements with the attackers to say like, hey, if you trigger a bunch of traffic on my network, I'll give you a kickback of the traffic that you generate for me, of the money that you're spending. And so what that happens is they're sending a bunch of text messages. Your phone verification provider is charging you for that. They're paying the money, and then they're paying the mobile network operator for sending the messages underlying whatever service you're using, right? And so they're ending up, the mobile network operator is the one that's ending up with the money. They do a kickback to the attackers. And so much like fraud in other industries, SMS pumping involves three main ingredients: a long and opaque value chain, and the exploitation of a service that is paid for by someone else. In this case, that's your business. You're the one paying for this fraud. And the kickbacks from the party receiving money, and that's the mobile network operators, to the party exploiting the service, which is the attacker. And so to understand a little bit more about how these kickbacks work, let's first talk about, I know not everybody is like really involved in the depths of telephony like I have to be sometimes, but let's talk about MNOs and MVNOs. So an MNO, mobile network operator, this is like an AT&T, a Verizon. These wireless carriers, usually like the big legitimate companies in most countries, own its phone numbers and the physical telephony infrastructure that they operate on. And an MVNO, a mobile virtual network operator, this is like in the US, a Boost Mobile, a Cricket Wireless, they're renting access to that infrastructure. And so they are technically still their own carrier, but they don't have the same control over the physical infrastructure. And that's important to some of the prevention strategies that you'll see here, because identifying certain carriers can help prevent SMS pumping, because we definitely see this more often with the MVNOs rather than the MNOs. And there are two main ways that the MNOs are involved in this SMS pumping fraud. And so the first case is pretty straightforward. The MNO or the MVNO is in on it, and they're giving kickbacks to the fraudsters. And so that's one of the most straightforward ways that you'll see this. And so in the second case, the fraudsters are working with an MVNO to inflate traffic. And so what happens there is the MNOs are paying the MVNOs to have traffic on their system, on their network. And so they're giving incentives to the MVNOs to say, like, if you bring a lot of traffic to my network, that's cool. Maybe I'll give you a bonus for that. Maybe I'll give you certain routes for bringing traffic to my network. And so the MNO may not care what the source of that traffic is, but if you're an MVNO and you've got like a buddy that can do this fraud scheme, you can go to one of these larger MNOs and say, hey, I can promise you a lot of traffic for your network if you'll give me access to some of these routes. And the MNO will say, cool, sounds good. I'm not going to ask any further questions. And then the MVNO runs this scheme, does generate a lot of traffic. The MNO is paying the MVNO for that because they're like, great, you generated traffic on my network. I'm getting a percentage of this cut. Everybody's happy. They don't really know or care who's footing the bill for this. But again, that's you, your verification service. But in any case, you're more likely to see this type of fraud with smaller operators or the MVNOs. And so it's not the type of thing that if you're sending a phone verification to an AT&T number, it's unlikely that AT&T is going to be running this type of scheme. So I've gotten some conflicting answers from some of my internal folks because I wanted to name and shame some of the carriers that are doing this globally, and we have a list of them, but unfortunately, legal reasons, blah, 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 they're not allowing us to do that because we're still working with them for some reason. But either way, this is the system you end up with. It's a system that puts money in the pocket of an MNO, which provides kickbacks to the fraudsters. And again, your app is the one that ends up paying for it. And if you weren't here when I first started talking about this, again, this can cost you tens of thousands of dollars, if not more. So I don't know if anybody's heard of toll fraud. This is something that if you've done any voice calling in the past, this is a specific attack that's been around for a while. And so if you're familiar with telecom fraud, toll fraud is probably the most common type of telecom fraud, and that you've probably dealt with this or heard about it. It's been around for many years. And so this is a very similar kind of revenue generating scheme as SMS pumping. Toll fraud, also called IRSF, International Revenue Sharing Fraud. It uses voice calling to premium rate numbers to generate revenue. And so they're making these really expensive calls, and they can do a lot of them, but they don't have to do quite as many of these expensive calls because they're on expensive routes where they're paying a lot of money per minute, per second, whatever it is. Excuse me. Also, like SMS pumping, the attackers are making money off of the revenue sharing agreements with the network operators that are in on this and that are controlling the premium rate numbers. But one of the nice things about what I'm talking about today is that most of the strategies that you can use to prevent SMS pumping can also be used to prevent toll fraud. All right, moving on to the good stuff. So how can you prevent your app from getting hit with this? I have a menu of recommendations that I'm going to offer. I think I have like 8 or 9 today that I'm going to talk about. But this is not an all or nothing situation. Like most security things, right? Like you can do a little bit now that will take you pretty far, and the more that you're willing to invest in this problem, the more that you're going to be able to protect your site. But obviously engineering resources are limited, so pick your battles, choose your fighter. You can see what makes sense for what you want to think about protecting. Think about the solutions that might be more relevant to your business and might be more easy to implement given whatever your infrastructure might be. But first, the one thing that I want to preface all of this with is, again, like how to detect that this is like the attack that you're seeing, that you're getting hit with SMS pumping, and it's not just a spike of legitimate traffic. So like I mentioned, you're likely to see this to sequential numbers, and so you'll see like 110, 111, 112, like at the end of the number, you'll likely see that these are just, they're ticking up because blocks of numbers are owned by the same mobile network operator, and so that's how they're able to say, these are the numbers that I want to trigger this to so that I can make sure that I'm getting money back to the person that I'm doing the revenue sharing with. As the fraudsters get more clever, numbers within the same block might be used. They might not be doing the same sequential blocks, but you'll likely be seeing it to the same carrier or to the same MVNO. And if they're abusing a phone verification form, one of the things that you're definitely going to see is that you'll see a lot of one-time passcodes getting sent, but never checked, because that's not relevant to this case. The only reason that that might happen is if you're suddenly doing a strategy where you're turning this off to someone if your phone verification completion rate gets dropped. So if you can think about, if you're monitoring the conversion rate there of the number of phone verifications sent versus divided by the number of phone verifications completed, checked, like the one-time passcode's good, divided by the number of phone verifications that are sent. That number is usually like 60 to 90% depending on your business. If that drops off completely, then that's a good sign that this is something that's happening. However, if this is the only protection that you make, then the fraudsters, again, might learn from that, get clever, start checking the phone verification so they aren't going to trigger your suspicions. But one of the first things that you can do is just detecting bots, right? So people are going to be scripting this attack. It's not something that they're necessarily going to be clicking through because it's not going to be as efficient. Lots of libraries, things like botd, CAPTCHAs that can help and detect and deter bot traffic. But really one of the most effective things that you can do is, we've seen small changes that people make into their user verification forms and their user experience to make a little bit more annoying for legitimate users. But it makes it more annoying to send mass amounts of SMS traffic. And so ensuring that your users confirm their email address before enrolling in phone verification or doing a phone verification or enrolling in two-factor authentication, it makes a small difference to the user, but users are also pretty used to doing an email verification before they have to do anything else. And so I think that's one of those things that's a small hit to the user, but it might make a big difference for this type of attack. Of course, rate limits can help with this as well. Carriers share prefixes, and so not only is the country code that they're going to be sending it to the same, but the prefix, so the first like 2 to 4 numbers of the phone number is going to be the prefix that they're using in order to determine the block of numbers that are being sent. There's a website, I think it's MNC. I forget it. If you look up MNC, MCC, there's a list of all the phone numbers that are available and the blocks that the number ranges that are controlled by different carriers. It's mostly accurate. I wouldn't use it as like a source of truth for the end all be all, but it's a good way to get a sense of like which number blocks are controlled by which carriers. And there's lots of services out there to like do a carrier lookup on a phone number. And so if it is an SMS pumping attack, again, you're probably going to see it being sent to the same prefix, and so you could potentially block that. In your rate limit numbers that are sent to the same prefixes. Other keys that you can use for your rate limits include the user IP, the geolocation, or the device that they're using. And again, because this is not like a DDoS attack, this can also come in, like the example I gave was a sudden spike in traffic, but this can also come in as a slower drip of requests. So you might see like instead of a spike, you might see like a larger number of messages getting sent, but it might be like kind of a plateau that's higher than you're normally expecting because they don't want to trigger a certain number here. And so that's one where they might learn that you have a rate limit and just stay right below that. And so you'll have to use this in conjunction with some of the other strategies. Another pretty classic thing that you can do is adding delays between requests for users. And so in this example here, you've sent an SMS verification code and you kind of like gray out the option to resend the code for 15, 30, whatever how many seconds you want to wait for the user to receive it. And some of this is just like the user experience of it is if you're scripting this, like a bot is less likely to, this is the equivalent of a deadbolt on the door, right? Like they're not as easy to get it through this scheme if you have to wait for the script to run again to send another user verification code. But a legitimate user is also beneficial too because if they request a code and they're like, oh man, I didn't get it, and then they just like didn't look at their phone, or they realize their phone's in the other room, or users are impatient, right? And so like you generally this is something we recommend for people anyway, of like you don't want to bombard a user with additional text messages. One, that's going to cost you more money even in legitimate use cases, but if the text message isn't arriving right away, requesting another one isn't always going to make the first one arrive faster. So adding that kind of exponential delay of like give it like a little bit of a buffer before you let them send the next one, even if it's like 10 seconds. And then specifically for toll fraud, we recommend leaving off the call me option in a lot of phone verification forms. And so there's legitimate reasons that you might want to have like a voice phone verification if somebody is doing that with your system. There's still a lot of people that only have landlines, especially if you cater to an older population. Not everybody is able to receive text messages, but because toll fraud is triggered specifically on the call channel, that's something that you might want to maybe leave off as an option or have somebody be able to like click through a couple of other screens in order to get to that if they need to. But you might not want to offer that right away. Something you can do to limit the scope of the verifications is to either allow or block certain countries altogether too. And so this is something that I mentioned that if you're only operating in certain geographies, and so if you're like a US government agency and you only want to be verifying users that have US-based phone numbers, and like make an allow list so that you're only sending phone number verifications to US-based numbers. And so that's something that you maybe your business is not global and you don't need to worry about that. Or maybe that's something that if you're sending a verification code to another number, that's something that's going to trigger step-up authentication. You're running additional checks at that point. So if you're not expecting users in Vietnam, maybe you're not allowing numbers to be sent to Vietnam. Or you can handle those like few one-off requests with support tickets or something like that if those users get blocked. Again, you can also use geographies to set the rate limits. So maybe most of your users are in the US, so you don't cap that, but you have stricter rate limits on European countries if you don't see as much traffic there normally. And then the next thing that you can do is just look into the phone number before sending an SMS to the phone number. And this can get expensive depending on like how much information you're trying to get from the number. But you want to be able to get more information from the phone number. And especially if you're doing this as sign up, this is something that you're not going to be doing all that often or repeatedly with a phone number. And so again, like this may or may not be cost effective depending on the situation, but this is where you can get like carrier information, line type information, so whether or not it's a VoIP number or something like that. This might be more valuable to you and cost you a couple of cents per call, but it's definitely cheaper in the long run than sending an SMS if you combine that with some of the other recommendations, especially using some of the other free methods that I've talked about to trigger a phone number lookup as a step when something seems fishy. That could be something that you can do and is another option that you can add into some of the stuff that you're looking into. And so this is another one that I mentioned. So if you'll know you're getting hit with SMS pumping if you see this one-time passcode conversion rate drop. And so know your baseline verification rate. If it's something like 85%, the people normally complete your verification. Like it's never going to be 100%. It just doesn't happen like that. But if that, so know your verification. If that suddenly drops by a significant number, then you probably have a problem. And this could be a good thing to set anyway because it could be an issue with your code. It might not be a fraud attack. It might just be like I deployed the wrong, endpoint for checking verification codes, and now only like 30% of users can get through it or something. So monitor the OTP conversion rates and alert if it goes below a certain threshold. And then you can also disable entire channels of verification if you're not using them. And so you can do this in your code. You can probably do this at your service provider level. If you don't want to have to think about voice toll fraud, then don't allow the call channel to go through. And again, that depends on your users, depends on your business. You might want to be able to verify those users in another way, but maybe you can verify those users through email. Maybe there's a different way that you can get that verification through. So some customers are okay with this, but like I said, there's still a lot of people with landlines, so your mileage may vary as well. And finally, the thing that I'd recommend is talk to your verification provider about this. They probably know this is a problem, might have a solution for you. We've discovered how to block this effectively at the service provider level, but we're still being conservative because we're wary of the false positives, right? We don't want to block the legitimate traffic. But aside from sharing the responsibility for fraud prevention, a lot of these strategies are useful beyond just the blocking SMS pumping. And so this is things like monitoring the OTP conversion rates to help expose other issues in your code, things like adding the smart retry logic, that kind of exponential back off for resending SMS codes. That can help improve the user experience as well. And again, you don't have to do everything. Just from an engineering laziness perspective, it's going to be easier to do things like adding the alerting for some of this stuff than it is to set rate limits by prefix, because you might not know which prefixes you care about yet. So start small, add some manual interference, and go from there. There's other things you can do too that I didn't even talk about, like detecting VPNs. You can use WhatsApp. WhatsApp doesn't have the same problem as SMS pumping because it's not using the carriers. So that's a good option there as well. And so I've written a lot about this in more detail. These are my slides if you want to look at this later. So the Preventing SMS Toll Fraud is basically a written recap of this entire talk if you want to check that out. So definitely recommend you can read more about this, and reference guide is a great place to start there as well. So I do hope this talk has given you some more insight into how SMS pumping works and how you can prevent it. I'm going to stick around if there's time for any questions. Once again, my name is Kelley Robinson, and thank you for listening.
Thank you, Kelley. So we do actually have to wrap, but I would urge you, that was great. Thank you so much, Kelley. I would urge you to find Kelley if you had any questions about her presentation. And we'll get started with the next one in about 2 minutes or so.